price goes up, quantity goes down. That's standard. There will be linear demand function. You may have some more complicated demand function which is not linear asymptotically. That depends upon a particular need. But here what I'm going to do is I'm going to start with linear demand function. Except that I'm not going to use this particular format. I will do a simple transformation and I will use this one, A minus B. Now from where did I get? Think of it. I get Q on one side. So it is as if, if I divide 1 by B is like minus, sorry, B equals A minus BQ. So I divide 1 by Q, whatever is 1 by Q, I can use coefficient, I thought it does than B. Right? So I'm going to use this kind of demand function. This is the inverse demand function. Talking about the inverse demand function, the inverse demand function is quantity demand equals to A minus BQ, and inverse demand function is P equals to A minus BQ. What is the idea there and why am I doing it? I'm doing a quantity model, concept model. And therefore, given this, that I should be able to figure out what is the optimum amount of quantity found there. So now, this is the demand function. If it was a monopoly, or irrespective of what kind of quantity, we have a cost function which is P of Q. So what kind of cost function will we get? This is called a fixed cost. You get a small variable cost and fixed. Actually, the cost function will be much more complex. A plus Q plus then a B Q squared or something. So it will be that kind of shape. But I'm not worried about what it is shape. Because whatever I am going to do, simple or complicated cost function, the result will be the same. So why am I going to complicate my life? I'm going to give it a linear cost function. So then, if the firm was a monopoly, then what will be the profit? It will be total revenue minus total cost. So what will be the total revenue? That will be P times Q minus total cost at P of Q. And what will be P times Q? P is already here, right? So it's A minus BQ times Q minus P of Q. Now what does a monopoly do? Select one feature, maximize the profit. So selecting one feature, maximize the profit would equivalently pick up a Q, we start so that this expression is maximum. So which one way to look at it is that D CR DQ minus BTC DQ that should be equal to 0 or marginal revenue equal to marginal cost. Right? This is what we have studied for monopoly. So in this case, that would simply mean A minus 2BQ minus marginal cost equals to 0. So Q equals to A minus the marginal cost divided by 2B. Right? If you just do that equalization, that would bring down to the parameters taken. It generates that always the same, marginal revenue equals to marginal cost. In fact, for anything you should do in economics, it's always marginal revenue equals to marginal cost. In some cases, marginal revenue becomes equal to 5, which is what we call 5 equal to marginal cost. But generally, in every case, marginal revenue equal to marginal cost. Economics is basically a cost-benefit subject. So you will take an action in the time, one extra unit from doing something like marginal revenue or marginal revenue is exactly equal to one additional cost which you incur from doing that. If you stop at less than that, then you could have made more profit. If you have, by producing 1 unit more, if you have done more than that, you could have reduced 1 unit and have got more profit. You will always stop at a manifold same time. So that's what is called the monopoly. How will it change when I look at a cycle? So what will change? This is not going to change. The demand function is there in the market, that doesn't change. So what is going to change? So what is going to change is, now the price which you have will depend not only about how much quantity I produce, it will depend upon what you buy. That's the original picture. Demand function is generic, that's in the economy, right? Demand function is for airline tickets. So the way you look at airline ticket and prices and all, that will change. You will have that. Or with the full, or with the car, you You already have that. The only thing which is the clear price is just a combination depending on how much quantity you will produce in one month. So how do I look at the demand function for oligopoly? If I say that there are two firms, I am looking at a special case for the duopoly. Oligopoly in general, when N is not very defined, duopoly is 2. There is absolutely no reason why duopoly is different from oligopoly. We study duopoly because activity has to track. We look at 2 and then we can argue, or wherever we can argue that whatever you have done for 2 holds for N equals to 7, just to just get understanding. So what we are going to do is that the demand function, the price, I am going to say is now therefore of the form Q1 is multiplied by form 1, Q2 by form 1. And what Q is the form? Sorry, what is the form? So what is the profit for form 1? Point 1. The profit for form 1 will be price which you get times the quantity which you produces minus the cost of producing that quantity. That's why I am the other Q1. Q1 is the quantity produced by form 1. And what is the profit for form 2? 3 times Q2 minus 3 times Q1. That is standard profit for form 1 and form 2. What are the forms doing? They are taking quantity in this case. That's the only choice they will decide what is the amount of quantity to be there. So therefore, we now realize that how action of one affects the action of the other. How does it affect? Assume one of the firms has produced a higher amount. Then what will happen? Price will go down. Price is common to both. If Q2 is suddenly very high, the price will go down. Price will go down for both, form 1 and form 2. But it does affect form 1, right? Form 2 is unit price. So this price is going to go down. This is okay, that quantity by form 1. Q1 is independent of what the other guy is. But the price is going to affect it, and therefore the action which they are taking will be affected. Similarly, action which is taken will be affected. Uno gave me solution to this particular issue. So how much will the two firms do, Q1 and Q2? In this case, the firms will be identical. If it is identical, what will it mean? That both of them are S plus TQ1. TQ is what function. Okay, it will not be identical. For example, one of them may have the fixed cost and one is variable cost, P1. And the other may have fixed cost and the T1 may be T2 or T1 may be T2. They have to be the same, they cannot be the same. That is generally how the total competition is done. There are some issues to be handled here, we will try and do that. But at this stage, I'm going to start talking about formal game theory. That's how this is a game theory model and how game theory is kind of used to handle the operation. And then I will try and show you how in game theory we are going to be solving these kinds of problems. My idea is to solve this particular issue. Now, before I go to game theory, let's quickly try to solve it. If you were to find out how much quantity Q1 and Q2 they will produce, in this, can, for example, you tell me what is Q1 star and Q2 star, given, let's make it easier, that both of them have the same cost function, they are identical. And given you the reverse demand function, you cost function. Can you just tell me how much Q1 and Q2 will be? Any guesses? Let's not try to kind of start working and take some time. How will you solve it?
Both the profits should be equal.
I know the both profit will be equal because they are identical. But what is the quantity 1 and quantity 2? The obvious way to solve it is, what I'm looking at is when I'm a farm boy, I'm saying, okay, given, I don't know what the other guy is, but I'm going to decided. Given it should have a particular value, Q2, how much should I produce? I don't know what the other guy is doing, by the way, but I'm saying that suppose I think that guy is going to produce 10 units, how much must I produce? I'll get an answer, right? So I'm clear about the answer. Then I'll ask, if you produce 11 units, how much must I produce? So I will try to calculate it. And then I will ask that between 10 units and 11 units, what is he likely to produce? I know if you produce 10 units, I must produce 10 units. If you produce 11 units, I must produce 11 units. If you produce a particular unit, I must produce something. However, out of these two, what is likely to produce? Now, I will decide what I am going to do. I cannot do this, see what is done, and then try and do it. So I will have a conjecture. That's called the rule of conjecture. Now, how do I solve this problem? I try to enter it and think. Right now, that guy is also thinking, what must I produce given what the rival is doing? The exact dilemma which I have is the same thing with his body. I am sitting here and thinking, produce how much must I produce? He is also thinking, if I produce then how much must he produce? Only thing you do not know is how much is the other party produces, the right system. How do I solve that? And that's exactly how the game theory thinking comes in. So I will not get too technical in the game theory, but I will define game as, games are usual. And we define game by set of players, there are different set of players. There are some rules. Then there are some actions people take in strategies. And then there are some payoffs. These are broadly what game theory are defined. So let's look at a simple 2x2 game. Let's try to understand how does one follow a 2x2 game. When I mean a 2x2 game, or you find it in most books, you begin as a 2x2 game, which means there are two players and there are two stacks. I can have two players and you find a number of strategies. I can have a strategy, which are like two strategies. And how do I look at two players? There will be like the following. So these are two sets of players. One guy is called the row player, the other guy is called the column player. So the row player has only two actions. He can either step up or he can step down. The column player also has two actions. Either he can step left or he can step right. So, game master players, I have players. Game master rules. The rules are game master strategies. Strategies are one of them can choose up or down, other can choose left or right. And game master also has payoff corresponding to each strategy. So what do I mean by payoff corresponding to each strategy? For example, the game could be such that every time you say up, assuming you guys are the row player and you guys are the column player, every time you say up and you say down, you guys get 4 and they get 3. You guys get 4, they get 3. That's how the game is done. Every time you guys say up and they say right, down. Sorry. Up and they say left, you get 4. You say up and they say right, then you guys get sector 2 and those guys get sector 1. If you guys say down, and these guys, they left, the weak box time here. So then these guys are going to get 2, and these guys are going to get vector 4. And the last box is when you guys say down, and these guys say right, then you guys get 2, and they get 1. So that's the game which we have designed. This is kind of the payoff. The convention which you are following, any number before the comma belongs to the row player, any number after the comma belongs to the column. So what is this thing about? Like, I am asking you guys to say either left, right, or up and down. Okay. Now, depending upon what you say, it will be your observation. For example, you will say, if you end up saying down, and you guys end up saying right, then down and right. So you guys get 2, you guys get 1. The only other thing which I am describing and to say is the simultaneous. Which means when you say up or down, you do not know what they are saying, and when they say left or right, you do not know what you guys are saying. It could have been sequential. For example, I will talk to one, and one of them says you say something, and then I tell them what you say, and those guys are going to do it. That will be sequential. And simultaneous, to begin with, where when you say something, you do not know what they are doing, and when you say something, you do not know what they are doing. That is simple behavior.
So both the quadrants have the same value?
It's very possible. For example, if you are not comfortable, you can make it 2, 0. It can be any payoff, right? Just a way I have deliberately checked the payoff different. Some change, some different, it doesn't matter. If you want, I can have 2, 0. If you want, I can take 2, 1. I am going with 2, 1, so the some of you must have written 2, 1 in your book, and then no point starting with 2, 0 and doing 1 again. Yeah.
Every time I say up,
I will solve it. Which is a pain. Now we are here saying that the issue is what is the solution we get? What is the solution? That is, we aim for actually we play between these two players. What can we expect to happen most times than not? That would be a solution. Or we call it an equilibrium. That is a solution is the equilibrium is the right stuff. Why do you say it's an equilibrium solution? When you get it, when you know why I'm calling it equilibrium, then you get most of the concepts set up. Right. When was the first time or when was the last time you studied equilibrium? How is equilibrium different from rest? Rest is stable too. This is rest. Yes. And this is equilibrium. Two forces from the opposite side is keeping the body exactly the way this is. But these are, I think there are no forces. But these are forces from the opposite side, it is keeping the equilibrium. Which means that in this game there is a chance of going all over. But the moment that is something which is equilibrium, then the chances of anybody moving from that is extremely small. That's how I'm conceptually thinking about the equilibrium. So what is the equilibrium of this case? If I propose something as an equilibrium, chances that something else is happening is extremely low. Not zero, but extremely low. Or even if it goes away, it might come back. That's stability of equilibrium. Equilibrium is what I said. It is the opposite forces will lead to. Stability is even if it goes out, it will come back. Stability doesn't mean that it will not go out. It can actually go out and it can come back again. So that can equilibrium process can be. Now how do we solve this? Simultaneous move. Easier to solve the problem. I am looking at this set of players. They do not know what these guys are doing, but they are thinking in this line. Suppose, I don't know, I am pretending to be the low player. I don't know what these guys are doing. They say, okay, suppose those guys put left. Then I can either play up or I can play down. How much do I get by playing up? What must they do? Yeah. If I think that those guys are playing right, what must I do? I can do it up. So in one case I surely do up, in another case I may be doing up. So what must I do overall? I must be doing up. That game, that result will be much more stronger if I were to just make it to list of 1. But when it's 1, then it becomes a no-brainer. Irrespective of what you are doing, I must be playing. If I have a scenario that is irrespective of what you are doing, this is the best for me, then I will say this is a dominant factor. This is a dominant factor because the strategy of playing up dominates everything else. So anything else I do, I will be worse off. So by playing up, anything else I do, I will be worse off. The earlier example when I had two, that would be a weakly dominant. Anything else I do, I may not be worse off, but I cannot be better off. What is the difference? Because suppose if for some reason good guys are actually played right, then we take to play up or down, you are not worse off. Right? If those guys are played left, then you should definitely worse off. But the moment if I increase it by one, then if you guys play right, then I am definitely worse off by playing down. So in this case, you guys have a dominant strategy of playing out. Do you guys have a dominant strategy? How are you going to read it? You are going to think that look, if they play up, by playing left I get 3, by playing right how much will I get? 1. What was they play? And if I think good guys are going to play down, then by playing left I get 4, by playing right I get 1. How much after? So what must they do? Yes. You guys have a dominant strategy. In this day, you guys have a dominant strategy. You guys have a dominant strategy. And the dominant strategy for them is up. Dominant strategy for you is left. It is 4x. So if you actually take this game over and over again, you know, what you will find is mostly the payoff is the payoff, the payoff. One is getting up and one is getting left. So one is getting 4 and one is getting left. So although you do not know what the players are doing, but you can perfectly well rationalize and guess what the players are doing. So eventually one of the things you also know is to, apart from this structure, that the players are rational, they can calculate what is best for them. And most importantly, will also endow the players with the excellent calculation capability and information capability. That is to say the following. Information capability. That we are assume both players are smart. Not only that, player A knows that he is smart. Player A also knows that B is smart. Because if they are getting B not smart, then something else might happen. We are really both players are smart. We also assume that player A knows that player B knows that A is smart. We don't stop it. That's really good. We also assume that player A knows that player B knows that player A knows that B is smart. And we go on. Since we are not restricted able to calculate. If you and I were to play a game of chess, if I challenge you in a game of chess right now, depending upon what information structure we have, the game might have very different outcome. So how many of you would want to, after this class, take a bet and have a quick, rapid fire round chess with you? Winner takes 1,000 rupees. How many of you? The same thing you can bring it to you. Then you don't have the money, you guys are extremely confused. Or you are unnecessarily putting premium on my ability to get it. Now, irrespective of that, depending upon what you think about this, that's the point you need to say. If you thought that I was a stupid guy, you would say anything particular. If you thought that I was a smart guy, you would say. If you knew that I also knew that you are a smart guy, then I would just think differently. If you knew that I knew that you knew that I was a smart guy, very different thing. That's very important. Because you might have a complete wrong guy, destroying quite a grandmaster, because the way he has done it, the grandmaster is thinking that he must have thought everything that otherwise you are running it. That's what we give it a completely valid information structure. So both of them know at any point in time, if player is not thinking that you are not smart and they are following you to something else. that will come out with example very well because it's actually a very simple example. Both of them have dominant category. Not really dominant category, they will have both of them with a dominant category. In Q1 they have three dominant category and therefore this is fine. And not only that, the outcome is system-based. That's a direct optimal outcome. One gets 4, other gets 2, there is nothing else you could have. Big probably exceeded filter is the maximum. I want to try it out, but the exceeded filter is maximum. So that's fine.